Welcome to the advantages of modernizing applications with containers. My name is Alex and I'm an AWS Solutions Architect. Stratus 10 is an AWS consulting partner with specialty areas in migration, DevOps automation, application modernization, and managed services. Today, we'll go over some of what containers are and why we use them, the benefits of containers, then we'll go over a case study in education, and then we'll cover some common pitfalls of using containers. So let's get started. First, why use containers? Well, a container is an open industry standard, and it basically allows you to package up your application environment and then deploy it in a virtualized environment that is separate from all your other applications. So we'll cover some key features of containers. First, there's immutability. This allows you to create consistent deployments and repeatable environments. And this is the guarantee that once you build a container image, it will never change. Next, we have speed. Since containers are smaller images that run on top of existing operating systems, this allows you to deploy faster with less operational overhead. And we'll go over more later. Finally, we have scalability. This feature is a direct result of a container's speed. Not only can you deploy quicker, but you can also scale up to several containers within minutes. This allows you to handle increased workloads with ease. So we'll cover some more benefits of using containers. First, we have rapid and efficient deployment and scaling. This builds off of the container's speed and scalability. Not only can you quickly scale up to meet demand, but the same speed allows you to quickly recover from failures. If a container fails, you can quickly replace it or roll back your deployment to a previous state, and your containers will quickly spin back up to what your environment was running before. This allows you to quickly scale up and down to meet demand or to recover from any failures that you might have had. Second, we have portability and consistency. The great thing about containers is that they package all of their dependencies into an image. This allows you to take them, build them, and run them anywhere. You could run them in a data center, you can run them locally, in the cloud, wherever it may be. Containers guarantee that they will run consistently each and every time. This also allows you to test your containers in the lower environment and then promote them up to a higher environment like stage or production, and you can do so confidently knowing that it will run exactly the same as it did in the lower environment when you tested it. Next, we have reduced operational overhead and reduced costs. So managing your environment is never the same. Your environment is never static. It continually grows, and containers used with the proper orchestration software will allow you to scale to hundreds of containers without much overhead. Additionally, you couple this with the auto-scaling capabilities of AWS, and you're able to scale down during low traffic times and scale up during demand rather quickly. So these two things will allow you to also control your infrastructure costs. You no longer have to keep static infrastructure running at all times for peak loads. You can scale it down and know that due to a container's speed, you can quickly scale up to meet demand and also save costs at the same time. And because you're already using a container orchestration software, you will be able to do all of the scaling and cost savings without having to hire too many people to manage the ever-growing infrastructure that you have. Finally, we have monitoring and security. So this builds off of the container's portability and consistency. Using containers allows you to build standard monitoring and logging directly into your image, so that your monitoring tools get deployed at the same time as your container. There's no more forgetting to install monitoring or making sure it's standard across all servers after you've already deployed it. You simply build it into your CICD pipeline, and you confidently know that once the container goes out into your environment, it already contains all of that. Additionally, as mentioned, with the proper CICD Pipeline, you're able to perform security scanning on your containers during the build process and fix any issues in your containers before it ever reaches your first environment. This allows you to remediate any fixes and be confident that once your container goes out into your environment, it is secure and all the logging and monitoring are properly installed. So all of these features and benefits of containers make them a really attractive option for your infrastructure. Next, we'll look at a case study. Peachjar is a communication and e-learning platform used in K-12 schools. Peachjar had a business challenge. They wanted to run specialized machine learning workloads efficiently and without excessive resources. And in searching for the solution, they had a couple of technical challenges. First, they were finding it hard to find an elastically scalable, cost-efficient platform for their machine learning and data science workloads. Second, they wanted to reduce their maintenance requirements for manually deployed virtual machines. They wanted to make it easier to scale up and to replicate their environments. Finally, they wanted to decrease their risks associated with delivering these changes and new workloads into their production environment. So notice how some of these challenges can easily be solved by containers. Some container benefits like portability and consistency can directly decrease their risks with delivering new workloads into their production environments, for example. Next, we'll look at how Stratus 10 implemented and delivered the solution for Peachjar. So first, Stratus 10 assisted in moving the containers for Peachjar to run on AWS Managed Kubernetes Service, or EKS. These containers were implemented to create a repeatable, scalable environment, to reduce costs, and to improve their performance. Stratus 10 migrated their VM-based solution to a containerized solution in EKS. At the same time, they also created CloudFormation templates using infrastructure as code to deploy their base networking, EKS, EFS, which is the file system, and any other supporting resources that was required by Peachjar. And this was done along with building their containers so that they could reliably deliver their machine learning and data science cluster to multiple environments and scale as needed. Not only can they be sure that the containers and their applications that they're testing and building monitoring into perform exactly the same in all of their environments, but they can also confidently replicate their environments using the CloudFormation templates that were designed. On top of all of this, in order to ensure that the containers are properly built and delivered to the environments, it is necessary to have an efficient CI/CD pipeline and one that is fully automated. So we'll review Peachjar's CI/CD pipeline next. So this is a diagram of the pipeline that was implemented, and this is fully automated end to end. So first we'll start with the AWS code commit on the left side here. And this is AWS's Git repository. This is where developers store all of their application code and all of the all of the Git pushes that will then trigger the CI/CD pipeline. The service that was used was AWS Code Pipeline, provided by AWS, and this is a managed pipeline service. And the first item that happens in this pipeline is it triggers using Git push from code commit. Once a developer pushes code commit, the pipeline gets triggered and then goes to the next step, which is AWS code build. And this is a tool that is used to build the application, in this case, the containers. The containers then go through the process of being built using a Dockerfile. They will install any monitoring, perform any security scans. Once all testing is complete, once the image is successfully built, it is then pushed to a container repository, in this case, Elastic Container Registry, provided by AWS. Next, it will go to the final deployment step, which is the AWS CloudFormation. As mentioned before, this tool will then deploy any of the underlying infrastructure that is required, and at the same time, it updates the Elastic Kubernetes cluster with the latest container image that was just built. In this case, it will update what's called a task definition in AWS, and this task definition will then point to the new image and then update the cluster service to be able to pull that new image and deploy it. So this, as mentioned, is automated from end to end so that Peachjar is able to simply commit to their Git repository, and then the entire process gets kicked off and they don't have to manage any of it. If there's a failure, they will know. If they have to retry, they simply make code changes, push to Git, and then wait and watch as the whole process runs from end to end. Next, we'll cover some common pitfalls of using containers. Now, I wouldn't necessarily say they're pitfalls of containers, more so of using them in the wrong way or not fully preparing like you should. So first, this is not refactoring your application. So we've seen many of the benefits of using containers, but in order to take full advantage of them, you need to ensure that your app is properly refactored. You can't simply wrap your existing application in a container and call it a day. You need to make sure your app configurations are split from your application code. Make sure you're passing them as environment variables into the container. If your app has multiple components, you want to make sure you split that off into different containers so that you can start and test each separate component and then deploy it separately. You can scale it separately. This makes it much easier to manage your application as a whole. So, as mentioned, without refactoring, containers are a little bit more difficult to maintain because now you have so much to maintain. Next, we have no automation. Using containers with no automation is a little bit difficult, having to continuously build them, having to continuously test them. You can also incur significant costs coming from inefficiently managing containers or high personnel overhead that requires managing all of these containers. So on top of CICD, you also want to make sure that you have a proper orchestration software that can deploy all of these containers out for you, like EKS or Elastic Container Service or ECS provided by AWS. This ensures that you can manage your ever-growing container infrastructure with minimal overhead. Finally, we have security as an afterthought. Built-in security is crucial to containers. You don't want to push containers out that are insecure or that haven't properly been tested. So you want to make sure that, coupled with your CICD pipeline, that you are scanning your containers, you're fixing the vulnerabilities, and you're also thinking of the security of the packages that your application is dependent on. You want to make sure that you're constantly updating them in your CICD pipeline and just pushing the latest and greatest out there along with your container image, and doing it at the beginning in your build pipeline and not after it's already been deployed in your environment. So remember all of these pitfalls, try to avoid them as you're building containers. I believe that's really the only way to truly see the value of using containers. So now that we talked about containers, the question is, when do you start using them? Well, the good news is that you can start now. So what are some next steps when starting to use containers? So first, as mentioned in the previous slides, you need to start refactoring your application, start thinking about what kind of orchestration service or software you want to use for managing your containers, and then slowly start migrating them as you build. I would start with some of your less crucial services. That way it gives you a chance to practice building the containers, to practice building the CI/CD pipeline, to be able to test some of the different processes and just get through the growing pains. That way, as you migrate your more crucial applications, you already know what to look out for, what to expect, and what to build. But what if you're not in AWS? Well, that's not a problem either, because AWS provides some excellent services, namely in this case ECS and EKS Anywhere. So we've talked about ECS and EKS being container orchestration software. You basically create clusters and run them in AWS. You can use these same services to run containers anywhere. You can run them in your data centers, in an office, or wherever there's a server. The only caveat is that the server needs to have an internet connection because it needs to communicate with AWS. So you create a cluster in AWS, you install agents on your servers that are on the edge, in your data centers, wherever they may be, and then you create the task definition files, the containers in AWS, and then AWS anywhere will then schedule your containers on your physical servers. That way you can continue to utilize your physical servers, as well as take advantage of all the great benefits that AWS has to offer. And on top of that, when you're ready to move to AWS, the transition is a breeze. You already have an ECS cluster, you already have a task definition, your container images are already in AWS, and your applications are already containerized. You simply change where you want your containers scheduled. Rather than your physical servers, you can have them run on EC2 instances on AWS or on AWS Fargate. That way you don't have to manage any physical servers. And that makes the transition to AWS a breeze. That ends our current talk. Thank you for watching.